We are going to start with sets. A set is a collection of, you can see, a set is a collection of well-defined objects. Well-defined means that there is no confusion about the characteristics of the elements in the given collection. It is denoted by a capital letter and the elements are written within curly braces. Let us understand what I mean to say by this. Now see, you can all see that a set is a collection of well-defined. I'll explain you with examples. A is a collection of orange, apple, and say some fruit, grapes. So everyone, the characteristic is that this is a collection of fruit. This is a collection of fruits. There is no doubt, and no one will try to oppose this characteristic that they are all fruit. The characteristics remain same. They are all a collection of fruit. See, I have written with the capital letter. These are your curly braces. These are your curly braces. The curly braces hai, and you start with a capital letter. Now, this is, let's take another example. So this is a set. Let us take another example. B, rich pupil in Delhi. Now, rich is an adjective. Now, there will be a confusion about who is rich and who is poor. Some people may claim that whose income are more than 1 lakh, they will say per month will say we are rich. Someone will say 50,000. But there is always a doubt. There is a doubt in this. There is a doubt that which persons will be considered as rich. So this B, so it is only a collection. It is only a collection. Only a collection. Now I take the same set, let us call it now C, and I write rich pupil in Delhi whose income is more than 1 lakh per month. 1 lakh per month. Now you can see this adjective has been modified by some more than less than quantity. That means we will only consider those people rich whose income is more than 1 lakh. इसका मतलब ये है कि अगर कोई किसी को अगर अमीर बोलना है तो ये अमीर जो वाला सेट है ये नहीं हो पाएगा, ये सब कलेक्शन बन के रह जाएगा. तो यहाँ पे हमने एक रेस्ट्रिक्शन डाला है. We have put a restriction, more than, less than, a restriction is there. So this is a set because this may be an infinite set, but still it is a set because we will only consider those persons whose income is more than 1 lakh per month. This is the story. Now see this. एक एग्जाम्पल देखा होगा क्लास 11 की किताब में. 11 good batsmen in the world. Now यहाँ पे देखो एक restriction है ना, more than, less than, तो this is a set. तो यहाँ पे गुड बैट्समैन है, कोई किसी को गुड बोलेगा, कोई किसी को गुड बोलेगा, तो दिस यहाँ पे थोड़ा कंफ्यूजन है इस वाले डी वाले में. एज गुड इज एन एडजेक्टिव, तो एज देयर इज अ कंफ्यूजन, there is a confusion or there is a difference of opinion of different people, difference of opinion of different people. Oh, wait a minute, just a minute, let me write with this. Different people, so it is a collection only, it is a collection only. Now take another example of class 11th. I remember E, dangerous animal in the world. Now this word dangerous is again an adjective, and now it depends upon which people consider which one to be dangerous. Some may say this is not that dangerous, this is dangerous. So again, this is not a set. The above is also not a set. This 11 good batsmen in the world is not a set. This is also not a set. They are all collections. Now let me write down a concept for you. Note, if adjectives are involved, yeah, dangerous, good, rich, poor, if adjectives are involved, then it may not become a set, may not become a set until a restriction of, until a restriction is given. For example, less than, greater than, equal to. जैसे कि हमने यहाँ पे देखा है, you can see, as we have seen here, rich people in Delhi. There was a doubt here. कुछ इसको उसको रिच बोलते, कुछ उसको रिच बोलते, परंतु यहाँ पे in this, rich people in Delhi whose income is more than 1 lakh, there is no doubt. हम उसी को कंसिडर करेंगे जिसका इनकम मोर देन 1 लाख है पर मंथ. सो हियर इज नो डाउट. सो एवरीवन विल एग्री विद द कैरेक्टरिस्टिक ऑफ दिस पीपल. इनका कैरेक्टरिस्टिक्स क्या है? दे आर ऑल हैविंग मोर देन 1 लाख पर मंथ. सो यहाँ पे जो ही लोग आएंगे जिनका इनकम 1 लाख पर मंथ होगा, वी विल कंसिडर दोज एज they are this adjective. Wait a minute, sorry, this adjective is now under restriction of more than, you may have less than, or whatever. So this is a very important point. Now let's write down this, that a note, all sets are collection, but all collection is not set. That's all. Now we will see how to write sets. Now this is two ways of writing sets. Let us write down किन तरीके से हम सेट्स को लिख सकते हैं. वे ऑफ राइटिंग द सेट. देयर आर दो मेथड्स हैं. एक है सेट बिल्डर फॉर्म. This I am doing for all those students who didn't have maths in class 11th and 12th, and those who had, they know it already. Set builder form. The other is the tabular form or the roster form. ROASTR, roster form. Now under tabular form, see what I write. Suppose I give you an example how to write this and this one. See, with an example it will be easier. I write A is 2, 4, 6, 8. See, यहाँ पे एलिमेंट्स को लिखा जाता है कॉमा के साथ, सेपरेटेड बाय कॉमास, एंड यहाँ पे इसकी कैरेक्टरिस्टिक लिखी जाती है. इसी सेट को अगर राइट अंडर सेट बिल्डर, द टेबुलर फॉर्म इज रिटन विद एलिमेंट्स इन कॉमा, and in set builder we write the characteristic. In short, I will write a x is such that, this colon means such that, ये colon का मतलब होता है such that x is 2n where n goes from 1, you take n equal to 1 to 4, n equal to 4. तो देखो जब x 1 है you will get 2, जब x 2 है when n 2 है, let me repeat, जब n 1 है तो you will get 2, when n is 2 you will get 4, जब n is 3 you will get 6, when n is 4 you will get 8. So this is the set builder form, this is the roster form. Class 11th में ऐसा एक प्रॉब्लम था 11th 12th में, you people have seen that. एक और था B. See, I always write with capital letter, then I write an equal to, and then I use curly brackets, curly brackets. This is curly braces if you say so. B, you write 2, 4, 8, 16, 32. This was an example of class 11th. So set builder form would be x is such that x is equal to 2 to the power of n. यहाँ पे 2 into n था, यहाँ पे 2 to the power of n. Here it was 2 into n, and here it is 2 to the power of n. N equal to 1, 2, or you can write like this also. Wait, you can write like this. That will be much more easier. N is 1 to 5. When n is 1, you will get 2. When n is 2, you will get 4. When n is 3, you will get 8. When n is 4, you will get 16. When n is 5, you will get 32. I now hope you understood what is the set builder form and the tabular form. This has been made clear now with an example. What I do is that, let me write down exactly now the statement under tabular form and roster form, and what we do in the, we see, these are the elements here with commas, these are the elements here with commas, we write the characteristics here of these elements here, and we write the characteristics here of these elements. ये 2 to the power of n के फॉर्म में है, ये 2 to the power of 2 into n है, वो कैरेक्टरिस्टिक्स लिखा जाता है यहाँ पे, और यहाँ पे लिखा जाता है एलिमेंट कॉमा के साथ. So let us now see roster form. Elements are written and separated by commas. Are written, separated by commas. Here we write the characteristics of the element, characteristic of the elements. This is the only difference, right? Let me draw the line. Now we'll go on to something more. Types of set. That is a finite set, then infinite set. The infinite set and finite set. Elements can be counted. Can be counted. And elements cannot be counted. This is the thing. Now I will introduce you. These are the two things already you know in class 11th and 12th. Now see, you have a set this A, you have a set A, and this is 2, 5, 7. So the number of elements in A is 2, and let us take natural number 1, 2, 3, 4, so and so forth. This is a finite set, and this is a infinite set. This is a infinite set. Now let us talk more about this. Now let us understand a new concept called countable and uncountable. Now countable is again of two types. This is finite and infinite. This is something new concept which you don't know in class 12. This we need. And uncountable is always uncountable infinite. Now see, with examples things will be clear. Natural number, you have 1, 2, 3, up to so and so forth. This is basically, though it is infinite, but it is countably infinite. Countably infinite. Countably infinite, natural numbers. Take natural union. I will explain you union little later. 0. So this becomes 0, 1, 2, 3. This is actually whole number. This is actually whole number which you know. This is also countably infinite. Countably infinite. Now let us see integers. Integers, some people write here or some people use this. Some books rather. 0, 1, 2, and so on and so forth. -1, -2, -3, so on and so forth. This is also countably infinite. Little later I'll explain you what exactly is countably infinite and uncountable infinite. Wait. Infinite. Now you have countably infinite for this Q, rational numbers. This is of the form P by Q, where Q is non-zero. So let us take the example of Q. You have seen this different number in small classes, 1.5, 1.5 bar, which means 1.555. This is also a rational number. This is also a rational number. This can be written as, this one can be written as 15 by 10. And this, how you should write. Write x is equal to 1.5555 and so on and so forth. This is, and then you multiply with 10. 10x is equal to 15.555555. Subtract this from this. You get 9x is equal to 14. And then x you get 14 by 9. So this is also a rational number. So rational number is of the form P by Q. And Q is also a countably infinite set. Countably infinite set. I'm taking this countably infinite and infinite uncountable idea from some very good authors. Now let's see irrational numbers. Irrational numbers. You denote it by QC. Irrational number. Irrational number. Now, which you have seen in class 10th as, you have seen these numbers, under root 2, pi, under root 3, something like 1 plus under root 3. These are all irrational numbers. Now let us see what irrationals are all. Now irrational are of two types. Algebraic numbers algebraic numbers and transcendental numbers. This is your transcendental numbers. Wait a minute. Transcendental numbers. I'll just tell you the example. This is under root 3, under root 2. These are pi, under root pi, comma, e, which has a value basically of 2.717. You may have seen in your smaller classes. These are all transcendental numbers. Now, this irrational number is uncountable. Uncountable. I'll just explain you within a minute what does this countable and uncountable mean. Hold on. Just listen to this. Now, this is countably infinite, but this is totally uncountable. So, uncountable plus countably infinite gives you this irrational as uncountable. Now you see what is algebraic numbers. See, in smaller classes, you've seen polynomials like this. X square plus 2, smaller classes. I'm talking about smaller classes. X square plus 4x plus 4. You had this root as plus minus, this is as minus 2 and minus 2. They satisfy this equation. So, these are the roots. Similarly, if you take x square minus 2 equal to 0, you will get x equal to under root of 2 plus minus. So this type of polynomial, this is also a polynomial, this is also a polynomial having a rational coefficient. You know what is the coefficient? Coefficient क्या होते हैं? जो x के स्क्वायर के सामने ये लिखा रहता है, यहाँ पे a है coefficient, यहाँ पे b है coefficient, यहाँ पे c है coefficient. A, b, c are coefficients of x square. X square का coefficient है a, x square's coefficient is a. B is the coefficient of x. B is the coefficient. B coefficient x का coefficient है जो x के सामने लिखा रहेगा, x square के सामने वो coefficients हैं. C equal to 0. Now these coefficients must be rational. That means ये solution जो x मिला है मुझे x under root 2 solution किसका है? Polynomial equation जिसका rational coefficients है, इसका 1 है, जिसका rational coefficient है उसका solution है ना. This solution under root 2 plus minus is a solution of a rational polynomial having rational coefficient. 2 is rational. Here x square coefficient is 1. That is rational. So this is an algebraic number. So let me write down roots of polynomial wait a minute. Just a minute. Polynomials having rational coefficients. Rational coefficients. Just say rational coefficients. I need to say, then I'll repeat it in Hindi. I'll repeat it in Hindi also. You have x square minus 2 equal to 0. Here 1 hai. This is a 1 here. This 1 and this 2 are rational. 1 is the coefficient of x square and 2 is a constant. These two are rational. So x square is equal to 2. My x square equal to 2. X is plus minus under root 2. So this plus under root 2 and minus this, sorry. This plus under root 2, this plus under root 2 and minus under root 2 are algebraic numbers. Now take another example here only for this. If I write x square minus pi, pi is not a rational number. Pi is not a rational number. So this is a polynomial. This will give me x equal to under root of pi plus and under root of minus pi. But these are not algebraic number. Not algebraic number. Not algebraic. Just a minute. Not algebraic. Not algebraic number as the all the terms here. This is rational, but this is not rational. As the polynomial here, let me wait. Yes, as the polynomial here, let me write down the meaning. As the polynomial here is not having rational coefficient, as the polynomial here doesn't have, does not have rational coefficients or rational coefficients. Now see what I mean. See, pi is irrational. This is rational. The polynomial is no more a rational polynomial. This is an irrational polynomial set of. This is not a rational polynomial, and these roots are no more. That's why algebraic. कहने का मतलब ये है कि x स्क्वायर माइनस पाई है, 1 इसका कोएफिशिएंट है, आगे जो लिखा हुआ है, x पाई रैशनल नहीं होता है, पाई इरेशनल होता है, और ये रैशनल है, तो द होल पॉलिनोमियल रैशनल नहीं है, तो x की जो वैल्यू है ये अंडर रूट पाई और माइनस अंडर रूट पाई, सो वो एल्जेब्रिक नंबर नहीं होंगे, इसलिए वो एल्जेब्रिक नंबर नहीं होंगे. आई होप यू गॉट द पॉइंट नाउ. आई टोल्ड इन हिंदी आल्सो, आई टोल्ड इन इंग्लिश आल्सो, बट दीज आर. So now come to real numbers. Let's understand real numbers. Real number is also uncountable. Uncountable. Let us see why. Uncountable. Because real number contains rationals which are countably infinite. Within a minute, I'll explain you what is countable infinite and countable finite. Countably. Wait a minute. Countable infinite, and this is irrational numbers. That, as I told you earlier, is uncountable. I gave you the reason above. I gave you the reason. Wait. I gave you the reason here. I gave you the reason here why this QC is uncountable. I give you the complete reason here. Now, the point is, next one is complex numbers. Complex numbers. Now, this is something new for those who didn't have maths in 11th and 12th. Let me drag it more down. Yes, now we will understand complex numbers very clearly. Here, though I have made you understand in my previous video also that this is a real, now no more, this is the real axis now, and this is, yes, I have told you this is the imaginary axis. Now the coordinate here is written like x plus iy. Now here the coordinate minus x comma y is written as minus x plus iy. Here minus x minus y is written as minus x plus iy, sorry, minus iy, and here x minus y is written as x minus iy. And I told you about conjugate and everything. Z equal to x plus iy, and the conjugate and conjugate, I am writing in short, conjugate z bar is nothing but x minus iy. तो जो एक्स वाई था उसको एक्स प्लस, बस वाई के सामने जो साइन है उसको आई लगाना, आयोटा. आयोटा इज अंडर रूट ऑफ माइनस वन. मेरे पिछले वीडियोस में देख लेना, उसमें बता रखा है मैंने पूरा. दिस इज आयोटा, दिस इज आयोटा, दिस इज आयोटा. तो कॉम्प्लेक्स कॉन्जुगेट में whatever the sign is front of I, you just change that sign. I के सामने जो भी साइन है उसको चेंज करना. I के सामने प्लस है तो I के सामने माइनस भी करना है. That is called conjugate of this, and उसको बोलते हैं हम Z bar. Z bar. Now see, operate this complex numbers. Yes, complex numbers are also uncountable. Now I'll explain you what is countable and uncountable. See, let us now understand. According to a famous mathematician, Cantor, in some between 16th to 17th century, some 16th or more than 17. I'm not exactly remembering the date. You can forget the date and the year. It is after 17th century, some 17 something. The thing is this, see, you know this, 1 is greater than 2, sorry, 2 is greater than 1, this is greater than this is greater than this, and so on and so forth. The first countable infinity is called alif naught. This way you write, you write like this. You write like this way, something like x, and then you put a naught. Then this is known as the first countable infinity. The first, rather I should say countable infinity. Rather I should say countable infinity. After that, it becomes C. This is uncountable, and after this everything is uncountable. 2 to the power of C, 2 to the power of 2 to the power of C, and so on and so forth. So this is what matters most. Now let us understand. I've done it in very short. So what do you mean by countable? अब तक जानते थे कि ये इन्फिनिटी अनकाउंटेबल होता है, परंतु नहीं, जो अलीफ नॉट होता है अकॉर्डिंग टू दिस मैथमेटिशियन, इसको अलीफ नॉट बोलते हैं. अलीफ नॉट. Oh, right, let me write down the spelling. It is called, wait a minute, it is called alif knot. It is called alif knot. N-O-U-G-S-T. Alif knot, and the symbol is like this, alif knot. This is some other word. Now you will see. This is the first countable infinity. अब तक जो जानते थे नेचुरल नंबर, इंटीजर, रैशनल नंबर, सारे क्या थे, इनफाइनाइट थे. देखो अब टिल नाउ यू न्यू natural number, integer, sorry, natural number, just a minute, natural number, then your integer, then your rationals, then your irrationals, then your real, then your complex. They were all infinite. But now after his classification, something became, I'm taking some authors have a different opinion. I'm taking only some will say, that is depends upon authors. I'm taking very standard authors. Now you have N, you have Z, let me write down Q, then you have N, union 0. I'll tell you what is union 0. This becomes actually whole number, what you know as whole number. These all are countable. These all are countable infinite. Countably infinite. And these are that is R, QC, irrationals, complex. They are all uncountable. Now let us understand what is known as the cardinality of a set. Cardinality of a set. Cardinality of a set. Now the number of elements in a set. Number of elements in a set. Now see, if you have a set A having 7, 6, 7, 9, 10, so it is denoted by, in some books it is written card, C-A-R-D, card A, or just like this. This is not mod. This is the cardinality symbol. So cardinality of A here, or if I write like this, how many numbers? 1, 2, 3, 4. This is 4. Now let us take some other set. Let us take B. They are all finite, whatever I'm saying right now. Suppose I have this numbers 8, 9, 10, 11, 12, 13, and all that. So you have 1, 2, 3, 4, 5, 6. The cardinality of B, or you may write C-A-R-D, card B is equal to 1, 2, 3, 4, 5, 6. Now take the natural number. If you take, now let me discuss with some space here because I need more space to make you understand. The cardinality of natural number let's say card N is card Z is card Q, all this cardinality of N or cardinality of N union 0 is all alif knot. The first, first uncountable infinity. Sorry, countable infinite. Countable infinite. They all have cardinality alif knot. They are all cardinal. They are countably finite. Countably infinite. Sorry, countably infinite. Countably infinite. Whereas the cardinality of R, the real numbers, is C. Cardinality of QC is also C. This is the first uncountable. This is the first uncountable. Rather, let me come to this picture. Let me tell you one thing. See, this I made now. This is the countably infinite number. This is the first uncountable. This is the first uncountable. This is the second uncountable. This is the third uncountable. This is the way it goes. Now we are not going into any more complications because we are dealing with the syllabus of GGSIPU. Though this is in your second semester, I need to tell you all this because there is a limit continuity of functions. What is functions? For that I have to tell you what is one function, one two function. For all that I am doing all this. Now you see कार्डिनलिटी ऑफ आर, क्योंकि तुम आपके सिलेबस में जीजीएसआईपी के सिलेबस में ये जो चैप्टर है सेट्स, ये सेकेंड सेमेस्टर में है, मतलब लिमिट कंटिन्यूटी ऑफ अ फंक्शन फर्स्ट सेमेस्टर में है. इसीलिए पहले फंक्शन पढ़ाने के पहले थोड़ा आइडिया सेट्स के बारे में देना जरूरी है. इसलिए आई एम गिविंग ऑल दिस सो दैट यू कैन कम टू नो व्हाट इज वन वन एंड ऑन टू फंक्शन. वन वन क्या होता है, वन ऑन टू फंक्शन क्या होता है. दिस इज वेरी इंपॉर्टेंट. नाउ cardinality of R and cardinality of C. The complex number is also C, small c. They are all small c's. Now see, next is operations on sets. I'll tell you why I used all this cardinality business. Right, later on, it will be easier for me to tell you one and on two function very easily. Now see this. Now see this. Operations on set. Operation on sets. Operation on sets. Now the first is union. I'll explain it with examples only. No more, no writings. Suppose A is 4, 5, 6 and B is 5, 7, 8. So it is denoted by this type, union. This is the union denoted by U type. B is you write the common element only one time. This element is here also, this element is here also. Write one time only, and all the uncommon elements. All the uncommon elements. That is. Let me write down. Write common elements one time and uncommon elements also. Uncommon elements also. Now this is A union B. Now see here देखो common elements एक बार लिखना है, ये common है, and these are uncommon. this ये और ये uncommon है, इनको सिर्फ एक बार लिखना है. Common elements को एक बार लिखना है और इन elements को भी लिखना है. That's why written common elements one time and uncommon elements also. This is union. Next is, with the same example I'll do intersection. Write common element only once. Write common elements only once. For example, I had A is equal to 4, 5, 6, and let me take B is equal to 5, 5, 6, 7, 8. Now common are this and this and this, and it is denoted by, see, it is denoted by A intersection B, the common. So this will only common elements 5 and 6. That's all. You got 5 and 6 as common. And suppose if I have, wait, let me introduce you to null set and then I'll tell you everything. Now, empty set, in this operations only I'm telling you because we need it. Empty set or null set or void set. Void. Void set. This is denoted as, there are no elements in the set. There are no elements in the set. In the set. एलिमेंट्स कुछ भी नहीं है सेट के अंदर. इट इज डिनोटेड बाय phi, ग्रीक अल्फाबेट phi, 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 ग्रीक अल्फाबेट phi. कहीं पे ऐसे एम्प्टी ब्रेसेस दिखाए जाते, ओनली एम्प्टी ब्रेसेस. कहीं पे एम्प्टी ब्रेसेस दिखाए जाते हैं, दैट इज एम्प्टी ब्रेसेस ओनली. बट रिमेंबर, if I write like this, if I write like this, then this is not empty set. This is not empty set. अगर मैं करली ब्रेसेस के अंदर, खाली करली ब्रेसेस के अंदर इस फाइव को डाल दूं तो वो एम्प्टी सेट नहीं होता है. दिस इज नॉट एन एम्प्टी सेट एट ऑल. नाउ दैट्स द पॉइंट. नाउ द थिंग इज, why did I write explain you null set, this empty set or null set? Why did I explain you? Supposing null set, wait a minute, supposing I have a set A which has got 5, 5, 6, 7, and I have a set B which has got 8, 9 and 10. Nothing is common. A intersection B, nothing is common. यहाँ पे कुछ भी common नहीं है, तो हम 5 लिखेंगे. That's all. मतलब ये इसका, दिस इज, कुछ भी इन दोनों में कॉमन नहीं है, इसलिए खाली है सेट. कुछ भी इंटरसेक्शन खाली है. दैट व्हाट आई मीन बाय दिस इंटरसेक्शन null set. There's nothing common. That's why I explained you null set. इसलिए मैंने पहले null set समझाया, उसके बाद ये इंटरसेक्शन में अगर कुछ भी कॉमन नहीं होगा तो फिर null लिखना पड़ेगा. That's why I had to tell you this. Difference of set. A set A has elements 2, 4, 5. B has element 5, 4, 6. A minus B, sorry, A minus B. See, you will write only those elements which is in A but not in B. And you will not write any element of B. See, you will write only element of A and you will not write the common elements, and also you will not write the elements of B. Elements of B, you will not write them. See, this and this are common, you will not write them. And you will also not write the element of C. So what is the only element left here? 2. So you will only write 2. I hope you got this. मतलब A में अगर एलिमेंट 2, 4, 5 है और B में एलिमेंट 5, 4, 6 है, तो कॉमन एलिमेंट लिखना नहीं है. 4 भी नहीं लिखना है, 4 भी नहीं लिखना है, कॉमन है. 5 भी कॉमन है, 5 भी कॉमन है, नहीं लिखना है. और एलिमेंट बाकी एलिमेंट ऑफ B नहीं लिखना है, क्रॉस कर देना है, नहीं लिखना है. सिर्फ एलिमेंट ऑफ A लिखना है. दैट्स ऑल. Similarly, B minus A. B minus A में देखो, you have 4 and 5 common in both of them. Now you will not write the element of A, but you will write the element of B. Now you will write this element. मतलब 5 और 4 दोनों में कॉमन है. A का कोई भी अनकॉमन एलिमेंट नहीं लिखना है और सिर्फ B का एलिमेंट लिखना है. That's why you got C. इसलिए C मिला, 6 मिला है. So you got 6. Now let us write the meaning of A minus B. Wait, let us write the meaning of A. Only elements of A will come which are not common with the elements of B, and no element of B will come. किसके लिए? A minus B. For A minus B. सिर्फ एलिमेंट ऑफ A आएगा जो कॉमन नहीं है B के साथ, और B का कोई एलिमेंट नहीं आएगा, वो मुझे A minus B देगा. I hope you understood. Similarly for B minus A. Now the next operation, that is this is called the complement. See, if this, there is a set A, let us say, set A, 2, 4, 5, 6, 7, and I have a set B in which elements are 4, 5, and 6. So B complements, in some books they write like this, in some books they write B like over on the top they write C. I'll use this. I'll use this. In some books, this is B dash like that. Wait a minute. B dash. In some books, they write B this. This is the best expression. B complement will be, देखो B के सारे एलिमेंट A के अंदर है, 4 भी है, 5 भी है, 6 भी. You've got all the elements 4, 5, 6 in A. So you will not write them. You will write only 2 and 7. Let me repeat. A has element 2, 4, 5, 6, 7. B has element 4, 5, 6. B complement is denoted by B dash or B on the superscript. You write C. Then you will write only those elements of A, and you will leave the elements of B which are in A. You will leave the elements of B which are in A, and you will write them. See, 4 is here, 4 is here, 5 is here, 5 is here, 6 is here, 6 is here. So the complement of B will be 2 and 7. You will leave the elements which were in this B complement. You cannot get A complement and then you write B, because A complement is not possible. You need again a set which contains A. A complement here is not possible. Here, A complement. If you want to write A complement in this case, it will be, if you compare these two, it is not possible. But if you want to write A complement, it will be nothing but 5. Because we do not have any other element. Here A complement would be 5, null set. I was telling this because basically, suppose you had a set C, then suppose it had 2, 4, 5, 6, 7, 8, then A complement would be your 8 only, nothing else. Otherwise, suppose this set C is not there. Suppose this is not there, C is not there, then I will not get this. I hope you I've been able to make you understand this thing. Let me repeat. A has 2, 4, 5, 6, 7. B has 4, 5, 6. The B complement is B dash. B complement. It's denoted by B dash or B on the top. It is C. B complement means you will not write the elements of B which are in A. Which are in A. That means 4, 5, 6 are in A. Don't write them. Write only 2 and 7. That's all. Now you want to write A complement. That's why I told, because there is no set which contains A here. Which contains A. So A complement will be 0 or for null. Will be null. But suppose I have a set C. Suppose I have a set C. Suppose I have a set C which contains A as well as some other element. Then A complement will then become 8. The only element here. That's it. That's the way it is. So complement means, in complement, basically what we do is this. Let me give you this. In complements, we take those elements which are not in that set, but in some set which this set is contained. Let me write. B complement. Suppose B is contained in A, contained in A, then B complement are those elements. B complement have those elements of A which are not common with B, which are not common with B, Let me make you understand. Let's see. Then we'll come to universal and all that. Wait. See, you have A and then you have B. The elements of B are 4, 5, 6. So what did I write? B is contained in A. All the elements of B are in A. B is contained in A. Then B complement have those elements of A which are not common with B. So you are having B complement here. You are having B complement. Wait a minute. You are having B complement here, which are having those elements of A. This element, and all these elements have been removed. कहने का मतलब ये है कि ये जो ए के एलिमेंट्स है और बी के एलिमेंट्स है, बी के एलिमेंट्स ए के अंदर है, उन एलिमेंट्स को नहीं लिखना है, सिर्फ 2 और 7 को लिखना है जो कि बी के अंदर नहीं है, वो बी कॉम्प्लीमेंट देगा। अगर ए कॉम्प्लीमेंट निकालना चाहूँ यहाँ से तो वो 5 देगा क्योंकि ए इज नॉट कंटेन्ड एनीवेयर। नाउ सपोज मैंने एक और सेट सी ले लिया जो ए को कंटेन करता है, तब ए कॉम्प्लीमेंट 5 ना आके तब वो वहां पे सिर्फ 8 आएगा, परंतु वहां पे मुझे बस सी मिलना चाहिए। आई शुड गेट सी which contains a. That's what I meant here by complement. Now come to the universal part. The universal's complement is phi, and phi complement is universal. I write universal in this manner. Otherwise, you will confuse with union. यूनिवर्सल का ऑपोजिट कुछ भी नहीं है, कुछ भी नहीं है का ऑपोजिट है यूनिवर्सल. दैट्स द पॉइंट. दिस इज द आइडिया. Now, one more thing. Suppose universal is made of, suppose I give you an example, 2, 4, 5, 6, 7. Now, A is 2, 4. And then A complement would be now, your A complement would be 5, 6, 7. Now, listen one thing. A intersection A complement is always null for anything. Whatever it may be, A intersection A complement is always null. A और A complement में कुछ भी कॉमन नहीं होता है. You can see, देख भी रहे हो, कुछ भी कॉमन नहीं होता है हर समय. And A union A complement will always give me back the universal. दोनों को यूनियन करोगे तो देखो क्या आएगा, 2, 4, 5, 6, 7 वो यही है, तो you will get universal. So you will get universal set. समझ में आया? अब next is, after complements and this, we will see power set. We will see power set. We have seen the cardinality of sets. Now we will see power set. Power set. The total number of subsets. The set which contains all the subsets of A, which contains all the subsets of A. Suppose, and this is denoted by P of A. Now suppose I'll give you an example. I have 2, 3, 4 subsets लिखो. Okay, इसके बाद मैं subset explain करूंगा. I'll explain subsets after this. 2, this is a singleton. 3, 4, then you have 2, 3, then you have 3, 4, then you have 2, 3, 4, and that is A itself, and 5. How many of them? 1, 2, 3, 4, 5, 6, 7. I think I left one more. 2, 4. Yes. 8 subsets. Now the collection of all these subsets is denoted by power set of A. Let us write down power set of A. This is, you have to write like this: 2, 3, 4, then 2, 3, then 3, 4, and 2, 4, and then 2, 3, 4 itself, and then you have your 5. So total is 8. So suppose A has cardinality of a number of elements in A is, suppose, n. Then power set A has 2 to the power of n sets in it. 2 to the power sets. Now these are elements here, basically behaving like elements. They're behaving like elements. 2 to the power of n subsets, I should say subsets of A. Subsets of A, which could be proper or improper. Now 2 to the power of n. Suppose, now let us see. Now cardinality of n is C. Alif naught. So power set of n. The power set of n is 2 to the power of alif naught, and this is C. Keep this in mind. Similarly, wait, let me write it clearly here. Cardinality, C-A-R-D, card n is this. Similarly, card Z is also alif naught. and the power set of Z is also 2 to the power of alif naught, and that is C. Now you have cardinality of Q, that is also alif naught, and power set of Q is also 2 to the power of alif naught, and that is C. Now you may ask the cardinality of R and C on Q. See, cardinality of even this union N union 0. So this is, let us call it B. Let us call it this set as B. Then cardinality of B would be also 2 to the power of alif naught, and that is C. Now cardinality of R is nothing but C. Cardinality of alif naught. Cardinality of B is C. Sorry. I made a mistake. Cardinality of B is alif naught. Wait. Cardinality of B is alif naught. And power set of B. Power set of B is 2 to the power of alif naught, and this is C. B means the whole thing. Cardinality of R. Cardinality of R is C. So power set of R. Power set of R is 2 to the power of C. That's the way. Similarly, cardinality of complex numbers is C, and power set of C again is 2 to the power of C. C. This is the way. Now, after this discussion, because I need to see all this again will be discussed in your second semester. I'm not going very deep into everything, though I got quite a lot deep into it. So let us now understand, after this cardinality, I think I need to tell you about, wait a minute, subsets and sets, and proper subsets and subsets. Now see, first I'll make you understand subsets, subsets and proper subsets, subsets and proper subsets, proper subsets, wait a minute, proper subsets. I need to make you understand this. This is very, very important. Now see, suppose I was said, I'll give you an example. 2, 3, 4, and 5. Now you have the set B. 2, 3. 2, 3 is completely contained in A. B is contained in A. B is completely contained in A. Completely contained in A. So B is a proper subset of A. This symbol denotes proper subset. Proper subset. Now next the next thing that I need to tell you, phi is a subset, rather proper only. Phi is a subset of every set. I'm not giving the proof. Every set. Proof is not, but to keep this thing in your mind. Phi is a subset of every set. Now, in this, now see, this was proper subset and denoted by this symbol. This is the way to denote. Now suppose I can say A, I cannot say A is less proper subset of A. I cannot say this. This is wrong. I have to say A is subset of A. Subset. This is just the subset symbol. See with this. This is the symbol of subset. Let me make you understand one thing very clearly from your smaller classes. See, this one behaves like 2 is less than 5, right? But here you cannot write 2 is less than 2. You cannot write this. You can write 2 is less than equal to 2. So this symbol somewhat behaves like this, and this symbol behaves like this. Now I think you will be able to understand what I want to say. This is not a proper, you cannot write this way. It is wrong, totally wrong, because A is not a proper subset, but let me write, A is not a proper subset. Proper subset of A, but is a subset of itself. A is a subset. A is a subset of itself. Of itself. Wait a minute. Of itself. So you have to write A like this. Now, after subsets, now in short, I'll make you understand functions. Subsets are done, proper subsets are done. Now, yes, let's do some Venn diagrams so that things are clear. The picture, Venn diagram, Venn diagram. Wait, Venn diagram. Venn, I don't know. Yes, Venn diagram. Diagram. Now you have this is the universal set. This is your set A. Outside of it is complement of A. So A intersection A complement is phi. A union A complement is universal. Next. Now you have these two sets. This is set A, this is set B. Now this much portion, let me do with colors. This much portion, this portion is A intersection B. Now this much portion, see, wait, let me use a different color, wait, let me use a different color. This much portion, this is what I am coloring. This much portion is called A minus B or A intersection B complement, or, and this much portion, wait, this much portion, I'm talking about this much portion, this is called B minus A or B intersection A complement. Now the whole thing, let me write it down. Wait, just a minute. Yes. Now the whole thing, this picture, let me include them. This whole thing, I mean to say, this whole thing is called A union B. This whole thing is called A union B. This whole thing is called A union B. Now, we will see more into this. I told you this. Now, you will see something very important. Let's keep the figure and see one very important thing. See, A is, let me use this. A is, see, this much portion and this much portion. So you can say A is A intersection B complement union A intersection B. Union this much portion and this much portion. A is completely this. Now, if I want to find the cardinality of A, okay, I forgot to tell you one more thing. Cardinality of A can also be written like this and also be written as like this. I'll use this method now. It will be easier for me. So n of A, cardinality of A is n of A intersection B complement plus n A intersection B. So shifting this on the other side, I have n A minus n A intersection B is equal to n A intersection B complement. So n A intersection B complement is equal to n A minus n A intersection B. This is a very, very important formula. See, the complement here becomes this. Now, similarly, you can do for B also. That you will do for homework. I'll write the B equation for you. Wait, I'll write it homework for you. That is the B equation. So B will be again this much portion and this much portion. So B would be, and you will do this as homework. B is equal to B intersection A complement plus, union, your union B intersection A, B intersection A. This you will do as homework. Find in this manner. What would be, I'm asking, what would be N B intersection A complement? This is your homework. Just the way I did the above one, you have to do it this way. Now let us use the same picture. Let us use the same picture, this picture I'm talking about. This picture we'll use, and then see what happens. Here I can write A, wait a minute, A union B is equal to A union B intersection A complement. Now understand what I want to say. See the picture. See this picture. This complete thing is, wait, this much portion completely, and this pink portion, only the pink color, this pink color. So you have this A union B is A union B intersection A complement. Now try to find out NA union B is equal to NA plus NB intersection A complement. Use this equation. So this will become NA B intersection A complement, which you will find from here. You will get the answer. This will be NB minus NA intersection B. Okay, I gave you the answer here for this. I gave you the answer. Fine. This is a very, very important equation. This one, the above one, this one. This one, this equation is very important, and the equation just what I found now, this one. This equation is very important. Now we will write this as N A union B is equal to NA plus NB minus NA intersection B. Now, see, this is a very, very important formula, the previous one and this one. Now let me show you another point, that is, if now I have three figures like this, 1, 2, 3. This portion is, this is A, B, C. This portion is, the white portion is A intersection B intersection C. Now this yellow portion that I am writing here, this is B intersection A complement intersection C complement. Similarly, this yellow portion here is C intersection B complement intersection A complement. Similarly, this yellow portion here is A intersection B complement intersection C complement. Now using this color, let me use this color. This portion is called A intersection B. This portion, they're all same. My figure has become a little clumsy. Otherwise, they all are the same size. Somewhat like that. A intersection C. I want to show you the Venn diagram portion and this common portion, this blue portion common between B and C. This is known as B intersection C. This is very, very important. Now we will derive for, see what exactly A union B means. Let me tell you. At least one of them. Union means at least. Intersection means both of them. Both. Intersection means both. Union means at least. Let me write down. Union, we will basically use the symbol union for plus, somewhat like that. And this means or at least one of them. Union means at least one. At least one. Intersection means multiplication. I'll use this later on. And means intersection, and this means both. Both, or if there are many of them, all of them. All of them. This is what it means. Now I need to find n, sorry, now I need to find NA union B union C. What I'll do, take this as A, take the whole as B, and apply this formula. Wait, this formula. I'll apply this formula. I'll consider one as A, the other as B, and then apply this formula. Now supposing I have, this will become NA plus NB. This is like behaving like B minus NA intersection B union C. Now be very careful now. See, this will become NA. Now apply the above formula on this. NB plus NC minus NB intersection C. You have this. Now minus, put N, write A intersection B, one part, union. I'm using once this. This is the distributive law. And this is A intersection C. This much. See what I did. This was like plus and B dot C. So I can write like A plus B. A dot, sorry. This is the distributive in this manner. Wait, let me tell you. This is A dot B plus C. So plus was like behaving like union, and this was behaving like intersection. So A dot B plus A dot C, that is A intersection C, B union A intersection C. I hope you understood how this has been written using this dot and plus symbol easily now. Now this is, मैंने यहाँ पे dot multiply और plus use किया है A dot B plus A dot C. तो ये dot जो है वो intersection का काम करेगा और plus जो है वो union का काम करेगा, इसीलिए ये वाला चीज ऐसे आ गया. Now let's erase this all. Now erase this all. You can stop the video and you could have written that. Now this is going to be NA plus NB plus NC minus NB intersection C. Now put the minus outside. This will behave like A and this will behave like B, and apply this formula again. Wait. Apply this formula. Apply this formula again. One will behave like A, the other will behave like B, and then you will have this formula. See, this will be NA intersection B plus NA intersection C. Then you have minus NA intersection B intersection A intersection C. This whole stuff inside the brackets. These are all in this much, and this much is all inside the bracket. Now open up the bracket. NA plus NB plus NC, then minus NA NB intersection C. Use open up this bracket, minus NA intersection B minus NA intersection C, and this will be minus and minus, that this minus and this minus will become plus NA. A intersection A will give me A with B, and C will, I'll just get A intersection B intersection C. This is a very, very important formula and you need to remember this. Algebra of sets. Now, this is what is called the idempotent law. If you take A union A, you will get A. A intersection A will give you A. This is associative law. A union B union C. A plus B plus C, you can say. This is nothing but A plus B and B plus C. First you do this union and then you do that union. It remains same. Same is the case for intersection. Commutative law, A union B is B union C. That is A plus B is B plus A, something like that. A dot B is B intersection C. That is A dot B is equal to B dot A. Now it is A plus B dot C is A plus B dot A plus C. And this is the De Morgan's law, which is very, very important. A union B complement will become A complement intersection B complement. When this union is there, you will get intersection. And when there is an intersection, you will get a union. The identity laws, these are A union phi in the null set will give you A. Suppose this place is empty and you have something A, something here. This is something here, and this whole thing is empty. If you take the union of this portion and the empty portion also, you will only get this portion. So, and the complements laws are this, that is A union A complement universal that I told you earlier. And the complement of universal is phi, and phi's complement is nothing's complement is the whole thing. And if you take the complement of the complement, you get back A. Now let's see some very important thing now. That is called your symmetric difference. That is called symmetric difference. Let me write it here. Write it here. Symmetric difference. Symmetric difference. That is, that is, that is A delta B. That is A delta B. A delta B is nothing but A minus B union B minus A, and B delta A is nothing but B minus A union A minus B, one and the same thing. Just writing one in the front and the other in the back. Now let's understand this with some Venn diagram somewhere here. See, basically this both, I mean to say this two both can be written in another expression is A delta B can be written as A union B, from which you have to remove A intersection B. Let me draw the diagram, Venn diagram for you. This is your A, this is your B. Then from this is the total thing is A union B. The total thing is A union B. This is A, this is B. The total thing is A union B, from which you have to remove this yellow portion, A intersection B, from which you have to remove this yellow portion, that is A intersection B. That is A difference B. I hope you understood this. Now two more little things, and then we will come to another very important topic. The thing is, I am talking of A intersection B complement is phi. Suppose is phi. This will imply A complement is a subset of B, or B complement is a subset of A. They may be both same or this whatever. Now suppose A intersection B is C. Suppose some C. This is not null. Then this implies C is a subset of A and C is also a subset of B. This is also an important. This is quite an important expression. This is now we are coming back to the Venn diagram. We saw this relation. From this diagram, we found out this relation. This relation I'm talking about. This relation completely. This one and uh, this one completely. This one and the whole this one. Whole of this one. The whole of this one. The whole of this one till here. Just a minute, till here. That means I want to talk about this complete structure. This complete structure is known as inclusion principle. So let me write it down for you. This is known as inclusion exclusion principle. Inclusion and exclusion principle of sets. Principle of sets.